For example 9. Once again, it's backwards with the x and y's. We have x second, y first, but it's still the y's line up, the x's line up, the numbers line up. Elimination is probably the easier technique on this problem. Looking at the y's, let's say if I want to get rid of the y's. All right, so this is positive 2y. I need this to become negative 2y for opposites to happen, so I multiply by negative 2. The top equation becomes negative 2y, and then we multiply negative 2 times 3x makes negative 6x, multiply negative 2 times 5 makes negative 10. The bottom equation I'm not modifying because it already has the positive 2y we're looking for, so the bottom equation stays positive 2y plus 6x equals 10. And you can see with that multiplication that I've done that the y objects are opposite like I wanted them to be. But through no fault of my own, these became opposites, but also these became opposites. And that can possibly happen sometimes in these problems. So you do what you normally do with the y's, they cancel. So negative 2y plus 2y cancels, leaving nothing y. But as a consequence of what we did to get rid of y, the x's also became opposite. They also cancel. So I eliminated y on purpose. I eliminated x by accident, but they're still both eliminated, which leaves me on the left-hand side, they're complete opposites. I'm left with the number 0. No x's, no y's. X got eliminated, y got eliminated, everything got eliminated. We simply have the number 0. On the right-hand side, negative 10 plus 10 also happens to equal 0. Now, this happens sometimes in these problems. When you have the y's being eliminated causes the x's to be eliminated, that is a situation where the lines are either the same line or you're looking at parallel lines. They don't have a solution or they have infinitely many solutions. So the way to make that decision is by the answer you get. If you get a true statement out of this, like we have here, that means that these two are exactly the same line. So if I were to graph them, not that I have to graph them, but let's just say I graphed them. And the top equation, let me make it blue. The top equation here would have a graph looking something like this. I mean, you can graph it on graph paper if you want to, but it has a slope of negative 3, y-intercept of 5, so it would have kind of a steep slope there and kind of go downwards. All right, this other equation is going to be the exact same equation, which means what's going to happen is you're going to get the exact same line. Any ordered pair making the top equation true makes the bottom equation true also, which means that we have any point on either line is an answer to this problem, which is more than just one ordered pair. Usually you have two lines crossing like this. There's one point where they cross. The blue line and the red line sit right on top of each other, which means that there's infinitely many solutions. So that's what we're going to write. Infinitely many solutions. There's no unique answer, there's infinity answers, and there's no way to really pinpoint which one's more important than anything else. So that will be the answer when this happens. So again, you perform elimination like normal. You get your object that you want to eliminate gone, but in the process of doing that, the other one gets eliminated also. Had I gone with substitution instead on the same problem, not that I'd have to, but I've already worked it out. But if I had gone with substitution, I would probably go with moving 3x over there. So the top equation would become y equals 5 minus 3x. And then I would go to the bottom equation, since we know that y, this one object, equals 5 minus 3x, both those objects, I would change this y into those two objects. So the bottom equation would then become 2 parentheses, keep in mind with substitution, you replace one thing with more than one thing, use parentheses. So 2y becomes 2 parentheses 5 minus 3x. And then plus 6x equals 10. Okay, so there's my substitution step. If I distribute the 2 through the parentheses like I'm supposed to, 2 times 5, 2 times negative 3x, I'm going to get 10 minus 6x plus 6x equals 10. And once again, by substituting 5 minus 3x for y, y went away, and by distributing and then simplifying, negative 6x plus 6x cancels. I'm left with 10 on the left equals 10 on the right. It's still a true statement. Not the exact same true statement, it doesn't matter. Again, both variables in the process of doing what we normally do got eliminated. The leftover statement is a numerical statement, just numbers. It's either true or false. If it's true, we're looking at one line sitting on top of the other. We get infinitely many solutions. That would be the correct answer to the problem when that happens.